Good afternoon. Thank you everyone for attending this session. We are going to do some live hacking today, and we're going to talk about the Equifax breach and would it have been contained, or how would the impact of that attack be contained? Were they using containers? My name is Benji. I am with Aqua Security. For those of you who do not know, Aqua Security is a startup based in Tel Aviv, Israel. We are focused on container security. And that picture is a picture of me. I decided to put it up because you have no real way of knowing whether it's authentic or I just stole it from Google Images. But no, that really is me at 12,000 feet skydiving. So let me ask a question. Why is this not working? There we go. Takes a bit of time. Okay, here is a quote from Forbes. There was a company that was recognized 3 years in a row as being one of the most innovative companies in the world. Does anyone have any idea which company they are referring to? Any guesses? Nope, not Apple, but good guess. Anyone else? No, not Aqua. Anyway, you'll be surprised to see the answer is Equifax. Now, there's a few things we can learn from this. Number one is that there is an absolute zero correlation between innovation and information security best practices, okay? But has anyone in this room not heard of the Equifax breach, what's been coined a mega cyber breach? Anyone? Okay, a couple of hands. So unless you've been, this is not working very quickly, unless you've been in some kind of underground bunker, this was a very, very high profile, one of the biggest high profile cyber attacks to take place to date. Equifax is the #1 credit rating company in the US. And what was interesting about this particular cyber breach was that 143 million customers were impacted by this breach. That's almost 50% of the entire population. And I'm going to go and stand here. And if you take a look at on the day of the breach, so when they announced the attack, the stock value, the share value of Equifax plummeted about $4 billion. That's about 25% of their market cap. And the reason this is actually interesting is if you look at the ingenuity of the hackers, the stock price was $143 on the day they announced it, and that was the same amount of people that were impacted by this attack. What was stolen, okay, was personally identifiable information. Usernames, customers, their addresses, passport information, in this case, social security, information that was in the Equifax database that should never have reached the public domain. Okay? Now let's take a look at the actual attack. So in order to successfully carry out this attack, the hackers had to do a few things. You can pretty much put it down to 4 key elements. Number one, they had to find a vulnerability. In this case, Equifax was using an Apache Struts web server. Struts is essentially a platform to develop dynamic web content. They had to be persistent. So once the attack, they compromised the server, they had to have some mechanism, essentially a backdoor, that allowed the hackers to keep coming back to the server and start exfiltrating the data out. Usually, one of the first things an attacker does is once they're inside the network, they will perform some kind of internal reconnaissance. It's often referred to as lateral network movement or east to west traffic. So once they're in the network, they want to map the critical assets within the network. Where is the database? Where is the mail server? Where is the intellectual property? And finally, they had to actually exfiltrate that sensitive data outside of the company. So the vulnerability that was used was, as you can see, CV 2017-9805. And what did it do? Essentially, this vulnerability allows for arbitrary remote code execution. That means once the hackers got into the server, they essentially had complete control of the server. Think of it as being root on the server, and obviously once they were root, they could do whatever they wanted. The exact flaw is regarding how a plugin that was used deserializes XML data without actually parsing it and looking whether that is valid or not. So for a minute, let's take a look and see what would have happened if Equifax, before we start the demo, if they were using containers and not a traditional server. Okay? So by show of hands, do you think this would have actually contained the damage and mitigated this attack? Good. That's about 40% of the room saying yes. So yeah, you're right. Let's take a look why. So if we look at the attack scenario, number one, if they got to a container, then obviously the container itself would have been compromised, but not the underlying host, okay? As you all know, from a container to compromise the host, I need to leverage some kind of kernel-level exploit, which is a lot more complex and would have required a lot more effort on the side of the hackers, okay? Thirdly, persistency. One of the key things that I said a hacker will do is install some kind of backdoor to enable the ability to keep getting back to this server. Now, if a server is up for a VM or a physical server is up for weeks or months, obviously because of the inherent ephemeral nature of containers, the hacker could have tried to install something or made any change, but within a few hours, that container will be dead, right? The orchestrator will come and instantiate a new image. So for every one server, I'm going to have tens or even hundreds of containers. That's obviously going to require a lot more effort for the hackers to retain this persistency. The lateral network movement, if I'm using containers, I'm going to have some kind of overlay network. That is, again, going to make it more complex for the attackers to penetrate the corporate network, because hopefully it's going to be a segregated network. Microservices. So obviously, containers are a great way to leverage microservices. Every one of these are basically self-contained. So if I compromise a monolithic application, let's take a SQL injection as an example, I've compromised the entire server, right? If I manage to compromise a particular microservice, then hopefully, if it's configured correctly, the other microservices should remain intact. And this one is actually, I think, one of the most important ones. Oh, shit, I've just seen that's upside down. Actually, it's not upside down. It's what we call reverse uptime. Does anyone here know what reverse uptime is? Okay, so everyone after this, go and Google. Diogo from Docker has a fascinating article where he talks about reverse uptime. Traditionally, with a server, the way we gauge the stability of the server is how long is that server up. If you go into a Linux server prompt, you type uptime. If the server's been up for weeks or months, it's usually a good sign. This is a stable server, okay? With containers, because of the way containers are just the way they work, okay, that is actually, it's the inverse. So the security posture of a container is inversely proportionate to the time that container is alive. The container, if you have a CI/CD pipeline and you leverage it as you should by continually updating the security patches, okay, a container should never be alive for more than a few hours before being reinstantiated based on the latest image, and that latest image should incorporate the latest security updates and patches, okay? So that's a great, again, once the CI/CD pipeline is constantly creating releases, there's no reason whatsoever to not incorporate the patches. And again, that is actually a very, I would say, a way of enhancing the security posture of your containers. Again, you can check it out afterwards. So the demo we're going to do, we have two containers. We have a victim container and we have an attacker container, okay? Hopefully none of you were in OWASP London, because a lot of this is a repeat of a demonstration I did there. What we are going to do is I'm going to upload an exploit. It's a Python-based exploit, okay, from the attacker to the victim, which will give us complete control of the victim container. Once I'm in the victim container, I can essentially do whatever I want. I will be root. And one thing I will also point out, well, you know what, let's start the demo. So if you can see here, before I actually do the demo, so this is the war file. This is the exploit that I'm going to upload. And note that this is a base64 encoded file, obviously, right? Because I'm uploading it to the Apache Struts server. One of the things I will have to do is pipe it to base64 to remove the base64 encoding. That is key, and I'll show you soon why that is important. So on the left, this is the hacker. So this is the victim. This is the victim container. And over here, we have the hacker container. And you should see in a second, the exploit starts working. Okay, that's obviously not real, but I love this slide. Okay, now let's do the real demo. But that's just an amazing slide. You have to use it. Reminds you of the Matrix. Okay. By the way, you were very quiet. I thought someone would say, what is this shit? So we have two containers here. We have our attacker and we have our victim. Again, these are very, let's just take a look at what these are. So if we look at the victim Docker file. So the victim Docker file is basically running Tomcat. It has a vulnerable version of that Apache Struts software, okay? And we are going to spin this up right now. So I have a simple script I can show you. Shell script that's basically doing a Docker run and setting up this container. The image that I'm using is called BP Docker Lab Victim Latest, right? So let's run the victim container. And while that's spinning up, let's take a look at the attacker container. So the attacker container is over here. You can see we're adding our exploit, so the webshell.war. Okay, that's what's going to be uploaded to our vulnerable Apache Strut server. Let's go into Firefox, and what we are going to do is spin up Apache. Let's check if our container is working. Okay, great. We have a container. We've connected to it. Let's see if Struts is working. Yes, we have this incredibly sophisticated application where we can type something and have it saved. And okay, so we have Apache Struts. It is working. No, we have to give it. Okay. Now, if I try and access the exploit, okay, the war file, obviously I'm going to get 404 because we haven't actually done the exploit yet. Now let's go to the attacker container. And what we are going to do is run the attacker container, again using a simple shell script. And we should see within about a few seconds that the exploit has been uploaded to the victim. There we go. We can see user local Tomcat web apps. If we now go into our, well, let's just refresh this page, okay, and see if it worked. Where are we? Okay, so I'm going to remove the protection, which was the second part of the demo. Okay, that's our virtual patching, which is you will see in a few minutes. Okay, and let's just run that again. So one of the things that you will see in a second is that as well as the image assurance, and we can hold it. I will wait, and we'll do this in order. So we are restarting our victim container again. And now we are going to, as we did before, run our attacker. And this time, once we see that the file has been uploaded, we should be able to go back to here, refresh it, and we have a prompt. Now, what can we do here? Well, let's take a look. Firstly, who am I? So I'm root in this container. What we can do? Well, we can do anything. I can look at the password file. Obviously, if I look at the processes that are running in here, we're going to have one process because it's a container. Okay, but interestingly, if the host is not configured correctly using cgroups or whatever you choose to use, you can potentially do some damage to the host as well. So let me ask some people in the room, what is this? Okay, this is a fork bomb. A fork bomb is essentially a bash function that will go into kind of an infinite loop and consume all the resources on the underlying operating system. This is a very primitive form of host-based denial of service attack. However, what's interesting in this case is that from within the container, if you have not configured your cgroups correctly, we can essentially perform a denial of service attack and bring down all the other containers and the host itself from within this exploit. So let's take a look at what that looks like. I'm going to, over here, run top. So how many processes do we have running currently? Sorry, how many tasks? We have 139 tasks. Look at what happens when I run the fork bomb attack from within the shell. I'm going to hit run. And you should see the number of tasks jumping up exponentially. Now, what that means is within about 20 seconds, the underlying host is hosed. Completely unresponsive. There's nothing I can do with this host except actually reboot it. So we now have 10,000 tasks, and that's going to keep increasing. So in order to get out of this rut, I don't have any other option. by the way, just to show you, if I go back into Firefox and now try and access the Apache server, I'm getting no response. So essentially, we've killed our host. So I'm going to go into VirtualBox. Luckily, I was prepared, and simply restart. Okay. So what we are doing now is we are restarting our underlying host, Docker host. And while I do that, I'm going to jump into the Aqua container security platform. Okay? And as you may have guessed, some of the things that we can do in the Aqua container security platform, well, number one is, this is the image that we are using, right? The victim. And if we look at the victim image, okay, we can see there are high risks. And the first high-risk identified vulnerability is this Apache Struts vulnerability. Now, what I'm going to do is show you how once we apply this policy, so our image assurance policy, what it does is, number one, it integrates with the CI pipeline, it scans the registry, and if we have a vulnerability, a known vulnerability, we prevent the image from actually running. So let's do that quickly. I'm going to go into the policy here, image assurance. I'm going to add disallow images based on CVE severity. I'm going to save that. I'm then going to kill the container, the victim container, and try and run the victim container again. So we now have our host back up, okay? And let's go into the victim container, run the same command we did last time. This time, Aqua is preventing this image from running. Okay, because we have applied the image assurance policy, and obviously we have situational awareness, meaning that we are constantly providing visibility to the security teams. If I go back here to our console, this would obviously get pushed out to Splunk or whatever log management system you're using. We can see here that user one, which is myself, tried to start this image, and it was prevented because it has a critical vulnerability. However, what happens where there is a disclosed vulnerability by the vendor, but no patch has been provided? Okay, that obviously isn't going to really help me because I have a mission-critical application running, containers running. I can't completely stop these images from running. And that's where we use our runtime profiles to apply virtual patching to the running containers. And that's what I'm going to do now. So our runtime profile, via a machine learning mechanism, profiles the behavior of the container to create a legitimate activity baseline. Everything that we see that we record is allowed, okay, is a whitelist, but everything else will be implicitly denied. So anything malicious or anything that deviates from that behavior will be prevented. So if we go now to our image, we are going to apply a runtime profile, okay, that it's called Struts Protection. Again, this is applying our virtual patching. So let's go here. We're going to say use an existing profile that's called Struts Protection. I click OK, and what that means is when I now run this, run this container, so I'm going to remove the image assurance policy. So basically saying, even if there is a critical vulnerability, I still want to allow this container to run. However, the virtual patching will basically mean that we cannot exploit this vulnerability. So what's key here is that even if the vendor has not provided a patch, okay, our virtual patching will render that vulnerability unexploitable. Let's see what that looks like. So I'm running the container. Again, this does have critical vulnerabilities, but we have removed the image assurance. What I'm now going to do is let's go to our attacker container. So, and once this is up, we are going to run the same exploit that we did before, okay, before we applied this virtual patching via our runtime profile. So I'm now going to run the attacker. And if we go to our console here, let's try again. Let's firstly check that Apache is actually running. So Apache is running. And if we go to the shell, despite the fact that we have applied the same exploit, okay, we've uploaded this, tried to upload the same file, it's actually prevented me from exploiting that vulnerability, even though I haven't patched the image. We're using the same image. And once again, if we go to our audit console in Aqua, we have complete visibility. And who can tell me why? So does anyone have any idea, based on this log, why, after I applied the runtime profile, was I prevented from exploiting that vulnerability? Okay, The reason is that in order to actually do that, you have to decode the base64 encoded exploit, right? And that was not part of the original baseline profile. So there's no reason that a Struts server should be running a base64 command. Okay, it's not part of its legitimate activity. And because this base64 deviates from that baseline that we created, when I tried to run the exploit and I piped it to the underlying base64 command, we prevented that from occurring. Okay, so what we've seen here, my time is, I'm over 2 minutes over, so I better quickly finish. So we showed, number one, the Apache Struts vulnerability using Aqua image assurance. We firstly showed you how we can prevent that image from running, both in the CI pipeline, for example, Jenkins, from being built, but also once it's pushed into production, we can prevent that image from running if it contains known vulnerabilities. But what happens with zero-day vulnerabilities? What happens with vulnerabilities where the vendor has published or disclosed the vulnerability, but there is no known patch? We showed you an example of applying our runtime profiles to give effective virtual patching and basically making it impossible for us to exploit that vulnerability. Thank you very much for your time.